Welcome to a new test and teardown video. This time it's another DC power supply. This one is from Oltronix from Sweden. It's called a power supply B703DT. This particular model exists in a few different versions with different readouts, different voltages, different current ratings and all that kind of stuff. But it's more or less the same kind of size and looks and all that. So yeah, this one is the one with analog meters. You can of course also get this one with digital meters, but then it's called DPM. Then it's a digital readout. And this one is only 7 amps for the low voltage. You can also get it in 10 amp. I kind of like the way that it's organized with red, yellow, green. Red, yellow, green. It's easy to figure out, easy to navigate around with. And I really love the voltmeter settings here. Those multi-turns. Wow, that is nice. So do you really need a digital readout when you have this super nice set? I'm going to figure out if this is accurate or not. Before I power this one up, there's a little weirdo thingy I wanted to show you guys. See, of course, if you're doing resistance measurements between the three outputs, you would expect all three to be completely individual, so you can parallel or series whatever you want to do, right? So this is how it goes from that one, right? But if we go between these two, that is a little bit weird. And if we keep it here, so there's a resistor and there's a capacitor, and in this way it ends like 5K. And then of course now the capacitor will discharge and whatnot. So let's go the other way and just charge the capacitor again. Let's see if we can get... I think they're a little bit dirty in here, so I can't really get a good connection. Before I had a good connection here, it ended at 4K the other way around. So I don't know exactly why it's a little bit new result every time I do these tests. Here we go. Now we have charged the capacitor and all that kind of stuff. So this way we have about 4K. So when this power supply can deliver up to 65 volts. So what happens if you put this one here? You have negative 65 volts over the 4K resistor. Is that a good idea? I don't know. So I definitely want to try and do that with an amp meter and see if that is a problem. So something is going to overheat. I've been doing a little bit of health check on this unit. I kind of like the way that they've written down the current settings here, and all that is quite all right. This one stops here and then it goes all the way down here. So this is pretty easy to fix. All I have to do is unscrew this one and fix that. This one is normal, but it's a little bit bent, so somebody dropped it. Okay. Well, of course we got this tracking, so you can change the meters from volts or amp. All that is fine. Tracking. So master is the master, right? Balance. So I bet in tracking, then I can change this one from like half of whatever the other one is, and then I can move both of them in a ratio or balance. Then I need to crank this one all the way up, and then the other one will be the master, right? This is something I need to investigate a little bit how that works. Otherwise, we have no tracking, and then they will be completely individual. Interesting. How are they communicating the different voltages between the red and the yellow when they're supposed to be completely isolated? That is a little bit interesting. Maybe that is the resistance here, right? So it's a current that goes from one to the other one, right? This is how they communicate analog. Just in case you're interested. 5.6 exactly kilos. That's quite funny. This is the rear side. We got a nice IEC connector, so I kind of like that. I bet this is mains entry on off, but then there's actually also this one. It says line switch and fuse on rear. So what is this switch doing here? This looks like somebody drilled this and modified this, because I don't see any text and anything around this one. What is this doing? Let's play a little bit with the yellow to the left and the red one to the right, and let's see how this works. So we are in tracking off, volts, and all that kind of stuff. So if this is 7.7 and I read 7.64, I mean, that is quite all right. I am actually impressed. This is difficult to do. This one is a little bit tight. You can loosen. So there's a lock. Let's see. Wow, manna. So you don't really need a digital readout, right? Wow, so this is definitely nice. Okay, so let's try the tracking. How is the tracking working? Okay, so the yellow one is the slave, I guess. So if I crank up, look at that. So master is, okay, let's go to 20. And what happens now if I play around with the balance? So 10 is 100%. And if I go to 5, it is 50%. So that is how it works, right? So what if I go 30 volts and 15? Almost. That is cute. It actually works. Nice. So how is the green one doing? Let's go over here. 0.5. That is of course how it works. This one goes from 0 to 5.5 volts, right? So we got one more digit, and there's a tiny little line here. So that is 0.5 volt. So this is 1. It is. How fast can we go? Maybe there's a little adjustment in here to crank up the voltage a tiny little bit here. So we're gonna see if that is also the case at 5. Yeah, okay, so this is what I'm looking for. The 5 volt needs a little bit of up tuning here, right? So I want to try and load this. I don't know if you can hear this on the video, but I can hear a lot of humming. Mechanical hum. I put some paper here behind the back because all the vibrations transported directly to the table and it was really loud. The idle is 12 watts. And what is... Oh dear. That is mains on, off. And now it is 0. Did you hear that? Oh man, listen. Okay, now I'm gonna do it again. Okay. Let's all the capacitors discharge. Okay, and then hear this. Okay, but before it was really bad. Oh. Now here's one more detail I figured out. The primary side of the transformer. So we got some tappings on the transformer, and this is actually what you do here when you switch the red power supply's range between 0 and 30, 0 and 65. So in the high voltage out range, it can go all the way to almost 70 volts, but it's specified to 65. And of course, if I crank down the voltage here, well, now we have charged the capacitors, but before, when they were discharged, I could only go to about 47. So right now they're just charged. Yeah, okay, now they're discharging. So this is the time it takes. I put my other voltmeter between the positive here to the right, the red one, and the negative on the yellow, just to see what is the leakage between those. So this is what we're looking at here, right? So it's only about 4 volts, but this is in 10 mega ohms. So, I mean, this is really not a problem. I was hoping that I could short this and not seeing any current, so we'll do that in a minute. I will just crank down the voltage a little bit. So I don't destroy any fuses. And as you can see here, I put my meter in current mode, and now I'm between these and I don't see any reading at all. So yes, you can truly do whatever you want, and there isn't any leakage I can see here, at least not a single milliamp. So that should probably be okay. Let's see how the current limit works. So now we're only playing around with the red output. I'm measuring volts here and current load with the other one here, right? So let's just give it a half an amp and see how that goes. I also switched the internal meter to amps, and it goes all the way to 1.4. So this, what we see here, should be about 0.5, a little bit hard to see because it's quite close here, right? And that will be my current limit. And I don't know if you can see this, but this one is green. So that is because we are in voltage mode. And if I, yep, and that will be about 0.5. And then it goes to current mode. And then I can, of course, crank down the current. Nice linear, nice stable. So all that works. All right. Let's try and do the same with the green power supply. That one is supposed to be able to give 7 amps. So again, we are monitoring the voltage and the current. Well, look at that. I just connected my load and then the voltage dropped. 4.8 volts. I don't know what is going on here. We are in 5 volt here and we see a little bit low. Remember, it was also a little bit low. So that is how it is. Okay, we turn on 0.5. Oops. And we drop to 4. What? So it's not able to give 7 amps at all. What is going on? And there's no response so far. Okay, if I take it all the way down, of course. So the current adjustment seems to be all right. Let me just put that for 3. Well, we got 4 amps. Okay, so I will turn off the load and then I will dial down the voltage to 3.5 and see if that is where it wants to be. So that is 3.44, and then I turn on my, oh no. There is a problem with the low voltage output. We have a problem. So what kind of current can I give it? This is 100 milliamps. Even that is too much. See? So what I think I am running on here, I'm running on the drivers, and the output transistors, they're dead. And this also explains why I'm not able to give full output voltage, right? See? I can't give all that I need, and it is a little bit low. Output transistors, they are blown. But I can't find a schematic. Oh no. What do you know? I was lucky to find schematics. Well, I actually didn't find them myself. I had Peter, the Google Meister, find them for me. So thank you very much. I will put a link in the description to the schematic, so you can also download the file and have a deeper look. I will just show the schematic here. So the first one is the 0 to 70 volt output, and that one is working. If you look to the bottom right, you'll see the sense and voltage system that goes from this supply to the other supply when that one is in tracked mode. And also look at the very bottom right. There's the ground output of this power supply goes down there to the right. So now we go and look at the 30 volt output. In the upper right corner here, we see the two traces going down to switch number 6. And at the moment, the switch is shown in individual mode. But if we push the switch up, then we are in tracked mode. And you will now see that ground from the first supply is now connected to positive on the 30 volt supply. So they're connected directly in series using that switch. So that is important to know, that they now go in series, in tracked mode. And now the 30 volt supply is controlled by the other one's voltage that comes on the top part of the switch 6. It goes into the balance system here. So you can select how much you want the other one to control this one. Last, we want to look at the power supply, the green power supply, and this is the one that is not working in the unit I'm showing here. And what can it be? If you look at the schematic to the bottom, in the middle but bottom, you see a 12 amp fuse. And in parallel with that fuse, you see a 470 ohm resistor. So that means you will have voltage output, but it cannot deliver current if the fuse is blown. But that resistor value seems to be a little bit too high for the type of current that I can load this unit with. So I don't think it is that, but definitely something I want to check out. Also, I got R30, a 12 milliohm sense resistor. So if that is blown, or if this is a much higher value, that could also give me the kind of behavior that I see. But if you go a little bit more to the left, you see Q5. Q5 is my my output regulator, my series regulator transistor. And Q5 is driven by a driver transistor called Q4. What if the base or the emitter is not connected on Q5, and Q5 is mounted on the heatsink? So that could potentially give me what I see. So then it is Q4 via R21 that drives my output, and when I load the output, I get only very little current output. So that could potentially be the problem. It could of course also be a Q4 that's not working, or it could be a few other things as well, but that will be the most obvious things I want to look at first. So let's look inside this beautiful power supply. This is the top side where they mounted all the power transistors. So that means this is the bottom. And as you see here, this is the bottom, just one simple screw, and then you pull out the two sides and the bottom. They slide in the grooves here, and it is that simple. Then you're in, and then everything else is just mounted nice and stable. It is, of course, you can't really go around here and access everything, but I think I could probably, with a little bit of luck, maneuver around here and figure out what is going on. The first thing I see is that fuse, and you also see the series resistor here, or the parallel resistor with that fuse, and I just checked the fuse, and that is okay. Also what I more or less did expect. There's one little warning I want to tell you about this this power supply. I don't know if you are how experienced you are with repairing electronics, and sometimes you just want to experiment a little bit with the repair of a power supply like this. But the entire board down here and all the connectors, they are the same type. See, it's the same 6-pin type, and you also see more or less the same kind of colors. They are a little bit different and so on, but you see some names on the PCB. See M12, and down here we see M13, or is that probably for that screw or whatever. But what I would take is a permanent marker and just write down this 12 that is written here on the PCB. Probably it's not the correct name and number or whatever, but that is something that I can recognize, and then I can definitely see that this is the right one. Okay, here it's obvious the cables here goes to this one, and of course I also have this video that I can scroll back in, and then I will be able to see this cable here goes here, and the wires, they look a little bit like that. Here the wires, they are a little bit different order. Yeah, they are reversed the order compared to that one. So that will tell me how to mount the connectors, because what if I need to go all the way in here? Then I need to completely disassemble the entire unit. And again, here it is maybe not super obvious, but it is the one most to the left that goes here and here, right? So I don't know if you can screw this up. Probably you could if you're a real what? If you're loopy? Noopy? Yeah.
It's a newbie, you know.
Loopy, that's... So here we go, red, black, and brown, and another kind of blackish kind of color. But I think it's good to have a little bit of video documentation here on those colors. We got an orange one here, a blue, red. Oh, you gotta see this. This is the on-off switch that somebody modified this unit with. So now we have a front plate on-off switch, and I kind of like that modification. I definitely would call it an upgrade, but it's just the implementation is not the most beautiful or smart. I don't know if you can see this, but the guy who drilled the hole drilled it a little bit too far up, so it is touching the PCB, and the metal of that switch is actually touching the PCB in a way where it's, I mean, I was looking with a magnifier here to prove it is, if it is really touching some of those tracks. That is not the kind of isolation distance I would recommend. So that is not so smart. And you have those Rifa capacitors, and they are a little bit cracked. Oh, about cracked capacitors. What do you call that one? Oh, there's some part of the... It is the red one down here I'm talking about. Let me focus on that. Can you see? Yep, we have a cracked capacitor. And I believe that one is called, what, C35 or something? Yes, C34. So this is C34. And it's just a little bit of cracked here, and there's a tiny little poofy-poof here. But the funny thing is, this was supposed to be 1000 micro, and it is 0 when I measure it. How funny is that? And if we look at the schematic, it is placed at a very important location for this power supply to work. Without this, the entire voltage reference system is just completely full of ribble. And that is, of course, why we didn't have correct output voltage. Look what I've done here. I put in a new capacitor, and I also trimmed a little bit on the fine adjustment. There is a little trimmer on the board where you can fine-tune the output. And here is the load 100 milliamps. If I turn off the load, see the output voltage is of course not affected by that. Let's see if it is linear. I am quite impressed. So this is definitely going to make somebody happy for the next 30-40 years. I think this power supply here is from 1984. At least that is what's written in the schematics. So this could be the design and so. Oh, look at that. Of course, I tuned it at 5 volts. If you want to know how to adjust the voltage, if you have one the same model, it is that one down here, P10. And of course, if you look at the schematic, it is easy to find that little trimmer here. And it is a little bit annoying they didn't write the numbers on the PCB here. They could have done that even in copper. But there are quite a lot of trimmers for all those alignments, but they didn't write anything here on this side where it's visible. But they did at least write it on the other side, and then you could poke around and see if you can read the values or read the text from the other side. And I'm just playing a little bit with the green potentiometer here for current limit. I put it for 4, and of course we're going to go down here and look at the amp meter. So I'm going to ask for 3. I said let's go for 3 amps like that. Okay, you see the voltage is dropping. Ah, that is actually my fault. It is better to take the voltage from the sense port and then pull the current here. This way you're gonna get your voltage output much more stable and accurate. Now you see my 3 amps, and if I turn off and on the 3 amp, and here we got the amp meter here is a little bit to the low, but what I wanted to see is what happens when I go to 4. Is it gonna go to current limit? Yes. So that also worked. How about I crank this all the way up? Let's see if we can pull 7. Just gonna dial it all the way up and see when it's gonna go blinkety blinkety. So that is 7. we have 7 watts, 7 amps output, and the input power consumption is 87 watts. So how long is it going to take before this thing gets warm? Well, I don't know. So I found all the correct trimmers to do a voltage alignment fine tune. So I did my very, very best. And I also marked the trimmers you need. That will be P10, P14 and P4. And I'll show you where they are located. Let me get this a little bit like that. So this one is P4. This is a 70 volt range. And down here is, that will be P14. I don't know if that is easy to see, but that is the one. And P10, that was that one. I of course marked all the trimmers so that you can easily figure out what you're doing when you got the schematic and all that. So there's only one last thing to say, and that is thank you very much for watching. Bye bye. Is there anything you want to add?
Yes, please like and subscribe.